Okay, this is OEH 5723, homework set 2, problem H, our third problem on this set. We are given an air sample that was collected for methylene chloride, and we found that it had a concentration of 32.9 milligrams per cubic meter. Unfortunately, our exposure limit is in ppm, so we want to know how many ppms this is, and we're going to assume that this sample was collected at normal temperature and pressure, so 25 C and 1 atmosphere. So methylene chloride, the formula is carbon, hydrogen. It's also called dichloromethane. You can look these things up online, methylene chloride, or you can, and MECl2. So what is the molecular weight? Chlorine is 35.5, and we have 2. Hydrogen, there's 2 of those, and there's 1 carbon. So 14 plus 71, right? What's that come out to? Anybody? Nobody's going to help me out. Anyway, so it's about 85 grams per mole, right? Okay, 85 grams per mole is our molecular weight. It's always good to just start off with that. So we're going to convert from milligrams per cubic meter to parts per million. Now, if you remember from class, we have a short form technique for this where we say milligrams per cubic meter. If we multiply by something that has volume in it, then we'll cancel out our volume, and if we divide by something that has mass in it, then we'll cancel out our mass. We'll have no units left, and we'll be able to go into ppms. And so it turns out that if we multiply by our molar volume at this temperature, so molar volume, or maybe I should do it as this. Volume of 1 mole in liters, and divide by our molecular weight, which is grams per mole, then our moles end up canceling. Our grams have have 3 orders of magnitude difference, and our volume has 3 orders of magnitude difference. That ends up automatically putting us in ppm units. We're already a million times larger than we should be. So this goes to ppms. But we need to know what is our molar volume. So at the given temperature and pressure of 25 C, which is 298 Kelvin, and 1 atmosphere, which is 1 atmosphere, then we need to calculate what our molar volume is. So we did this on the first problem F, so I'll refer you back to that, but it's just plug in to the PV equals nRT, so V equals nRT over P. We have 1 mole, we have our gas constant, 0.08206, and I'm not putting units because I'm just doing this quickly. Our temperature is 298 Kelvin, and then our pressure is 1. And this should come out to 24.45 liters. So the molar volume of a gas at normal temperature and pressure is 24.45. You should probably just go ahead and memorize that. You will memorize it eventually. I still remember it from 15 years ago when I was doing undergrad. So we can plug this in now as 24.45 liters. Sorry. That's where our molecular weight goes. So our molecular weight is 85 grams per mole. Our molar volume is 24.45 liters. And this gives us ppm. So we started off with some milligrams per cubic meter. In the problem, it was 32.9. So 32.9 milligrams per cubic meter. Is that showing up? Yeah. It's a little bit slow. Anyways, 32.9 times 24.45 divided by 85. And so we get 9.46 or 9.5. 9.5 ppm. Again, remember, we need to kind of be respectful of our significant figures. There's no reason for you to be giving me lots and lots of decimals on this, because we don't have enough information for us to have confidence in reporting that data. If we have no confidence in it, then it's meaningless. If it's meaningless, then it's just wasting our time. So, 2 significant figures is about all that we can expect from this, because we're given 1 atmosphere and 25 C, so we really only have 1 or 2 significant figures there. So this is our ppm. And that's the answer to the question. What was the concentration? 9.5 ppm.